The outer union operation was developed to take the union of tuples from two relations if the relations are not type compatible. This operation will take the union of tuples in two relations R, X, Y, and S, X, Z, that are partially compatible, meaning that only some of their attributes, say X, are type compatible. The attributes that are type compatible are represented only once in the result, and those attributes that are not type compatible from either relation are also kept in the result relation T, X, Y, Z. Example: an outer union can be applied to two relations whose schemas are student, name, SSN, department, advisor, and instructor, name, SSN, department, rank. Tuples from the two relations are matched based on having the same combination of values of the shared attributes, name, SSN, department. If a student is also an instructor, both advisor and rank will have a value, otherwise, one of these two attributes will be null. The result relation student_or_instructor will have the following attributes: student_or_instructor, name, SSN, department, advisor, rank. Q1 is the example of how to retrieve the name and address of all employees who work for the research department. Q6 is the example of how to retrieve the names of employees who have no dependents. This slide shows the examples of queries in relational algebra single expressions. Q1 is to retrieve the name and address of all employees who work for the research department. Q6 is to retrieve the names of employees who have no dependents. A relational calculus expression creates a new relation, which is specified in terms of variables that range over rows of the stored database relations, in tuple calculus, or over columns of the stored relations, in domain calculus. In a calculus expression, there is no order of operations to specify how to retrieve the query result. A calculus expression specifies only what information the result should contain. This is the main distinguishing feature between relational algebra and relational calculus. Relational calculus is considered to be a non-procedural or declarative language. This differs from relational algebra, where we must write a sequence of operations to specify a retrieval request. Hence, relational algebra can be considered as a procedural way of stating a query. The tuple relational calculus is based on specifying a number of tuple variables. Each tuple variable usually ranges over a particular database relation, meaning that the variable may take as its value any individual tuple from that relation. A simple tuple relational calculus query is of the form t_cond t, where t is a tuple variable and cond t is a conditional expression involving t. The result of such a query is the set of all tuples t that satisfy cond t. Example: to find the first and last names of all employees whose salary is above $50,000, we can write the following tuple calculus expression: t.fname, t.lname employee, t, and t.salary greater than $50,000. The condition employee, t, specifies that the range relation of tuple variable t is employee. The first and last name, projection name, name, of each employee tuple t that satisfies the condition t salary greater than $50,000, selection sigma.salary greater than $50,000, will be retrieved. Two special symbols called quantifiers can appear in formulas. These are the universal quantifier and the existential quantifier. In universal quantifier, every tuple in the universe of tuples must make f true to make the quantified formula true. In existential quantifier, every tuple in the universe of tuples may make f true to make the quantified formula true. Informally, a tuple variable t is bound if it is quantified, meaning that it appears in an t or t clause, otherwise, it is free. If f is a formula, then so are existential quantifier, f, and universal quantifier, f, where t is a tuple variable. The formula existential quantifier, f, is true if the formula f evaluates to true for some, at least one, tuple assigned to free occurrences of t in f, otherwise existential quantifier, f, is false. The formula universal quantifier, f, is true if the formula f evaluates to true for every tuple, in the universe, assigned to free occurrences of t in f, otherwise universal quantifier, f, is false. Retrieve the name and address of all employees who work for the research department. The query can be expressed as t.fname, t.lname, t.address employee, t, and d. Department, d, and d.name equals research and d.number equals t.dno. The only free tuple variables in a relational calculus expression should be those that appear to the left of the bar. In above query, t is the only free variable, it is then bound successively to each tuple. If a tuple satisfies the conditions specified in the query, the attributes fname, lname, and address are retrieved for each such tuple. The conditions employee, t, and department, d, specify the range relations for t and d. The condition d.name equals research is a selection condition and corresponds to a select operation in the relational algebra, whereas the condition d.number equals t.dno is a join condition. Find the names of employees who work on all the projects controlled by department number 5. The query can be e.lname, e.fname employee, e, and universal quantifier x, not, project, x, or not, x.num equals 5. Or, existential quantifier w, works _on, w, and w.essn equals e.ssn and x.number equals w.pno. Exclude from the universal quantification all tuples that we are not interested in by making the condition true for all such tuples. The first tuples to exclude, by making them evaluate automatically to true, are those that are not in the relation are of interest. In query above, using the expression not, project, x, inside the universally quantified formula evaluates to true all tuples x that are not in the project relation. Then we exclude the tuples we are not interested in from R itself. The expression not, x.num equals 5, evaluates to true all tuples x that are in the project relation but are not controlled by department 5. Finally, we specify a condition that must hold on all the remaining tuples in R. Existential quantifier, works _on, w, and w.essn equals e.ssn and x.number equals w.pno. The language SQL is based on tuple calculus. It uses the basic block structure to express the queries in tuple calculus. Select list of attributes. From list of relations. Where conditions. Select clause mentions the attributes being projected, the from clause mentions the relations needed in the query, and the where clause mentions the selection as well as the join conditions. SQL syntax is expanded further to accommodate other operations. See Chapter 8. Another language which is based on tuple calculus is QL, which actually uses the range variables as in tuple calculus. Its syntax includes range of variable name is relation name. Then it uses retrieve list of attributes from range variables. where conditions. This language was proposed in the relational DBMS INGAS system is currently still supported by Computer Associates, but the CUL language is no longer there. This is the example query using domain calculus. Retrieve the birth date and address of the employee whose name is John B. Smith. Query. Abbreviated notation employee, QRSTUVWXYZ, uses the variables without the separating commas, employee, QRSTUVWXYZ. 10 variables for the employee relation are needed, 1 to range over the domain of each attribute in order. Of the 10 variables Q, R, S, Z, only U and V are free. Specify the requested attributes, date and address, by the free domain variables U for date and V for address. Specify the condition for selecting a tuple following the bar. Namely, that the sequence of values assigned to the variables QRSTUVWXYZ be a tuple of the employee relation, and that the values for Q, name, R, minute, and S, name, be John, B, and Smith, respectively. In this chapter, 2 types of relationals have been covered: relational algebra and relational calculus. In relational algebra we have learned unary relational operations, relational algebra operations from set theory, binary relational operations, additional relational operations. Examples of queries in relational algebra. In relational calculus we have covered tuple relational calculus, domain relational calculus. For attendance record, please type your matric number followed by visit and watch at the comment area. If you have any question, kindly put it in the comment area. Stay at home to stop the spread of COVID-19.